Okay, hello everyone. This is going to be a continuation of the introductory lecture that I presented on introducing sensation and perception. Now remember that sensation is basically refers to the whole set of processes involved in um, information, sensory stimuli, basically stimulating the senses, and so the information getting in. Okay, whereas perception is how the brain interprets um, those sensations that have made it in and have been detected by the sensory receptors that we have. So today we'll talk about perception as interpretation. So the brain interprets or explains, if you will, sensation in ways that involve three major factors. The first one is sensory adaptation, in which the brain adapts to changes that are occurring in our environment. Two is perceptual set, our readiness to perceive or to see or to interpret the stimuli in a particular way based on our expectations and other psychological states that we may at the moment be in. And third, there's context or frame of reference. So the surrounding context of a situation can affect how we perceive a stimulus, how we interpret the stimulus, indeed, how we actually experience it. So sensory adaptation is a very important process because we need to be sensitive to and respond to novelty, change in our surroundings. So in order to accomplish this, our senses will tune out a constant stimulus. A constant stimulus is something that's no longer, shall we say, useful. And so we adapt to, sensory adapting basically involves the tuning out of something that is constant, something that is continuously there. So, for example, you get a rock in your shoe, it's bugging you, but after a while, you might not even, if it stays there, you might not even notice anymore. You have adapted your senses, in this case, the sense of touch, and has sort of tuned it out. It's less sensitive to that. The ticking of a clock. You may be acutely sensitive or aware of the ticking of a wind-up clock when you enter a room in which there is one, but after a while, it might become you become oblivious to it, and it might actually be difficult to sense after a while. Now, this kind of thing, when we talk about visual sensory adaptation, we don't notice in the visual sense that kind of adaptation too much as we do in the other senses, because normally our eyes are constantly moving. We call them saccadic movements. Our eyes are constantly moving. As you recall, when we talked about the split brain, this is why you have to have a very controlled environment in order to kind of separate the two hemispheres, so someone with a severed corpus callosum doesn't get information going from one eye to the other, because the eyes are constantly moving. I'm sorry, from one side of the brain to the other. Our eyes are constantly moving, so we're continuously getting a slightly different image. So so there is no stimulus that's going to be completely constant if given that our eyes are completely moving. So there's really not much to adapt to. However, if you concentrate on keeping your eyes in one spot, you'll see the effects as your eyes adjust to stimuli. For example, in the following slides. But this is something that you can study for yourself in other ways by focusing on a particular point and gradually seeing that point and the surrounding and the stimuli that constitute it, kind of like fade out. Okay, so that's sensory adaptation. Now, perceptual set is basically our expectations, what we expect to see. So what we expect to see, what we're primed to see, or what we're motivated to see, influences what we in fact do see. Okay, so as I mentioned in the previous lecture, perceptual set is an example of top-down processing. So we look at this stimulus, and so what is that? Is that the Loch Ness Monster or a tree branch? Well, someone out hunting for and believing in the Loch Ness Monster in some Scottish lochs or lakes, okay, might see that and say, holy cow, I've just seen the Loch Ness Monster, okay. And it may very much look like a monster to that person who has the expectation of seeing it. On the other hand, in all likelihood, it's just a tree branch, and that may be what you or I see, given that we're not expecting to see the Loch Ness Monster. Flying saucers. Well, if you're expecting to see flying saucers, if you believe in them, if you want to see them, that might be what they look like to you, but in all likelihood, others might see them merely as clouds. So you can see how somewhat ambiguous stimuli is subject to interpretation, and our expectations would affect those interpretations. So perceptual set can be primed. So what I want you guys to do is to spend a little time. Let's take about 10 seconds to concentrate and focus on the old woman on the left side of your screen. Okay, you can see that old woman right there on the left side. So let's focus on her. Okay, you see her mouth, see everything. Looking, there's her eye, there's her big nose, big chin, kind of like a witch. So look at that old woman. Okay. So the question is, what do you see there? Okay. Given that you were looking at the old woman, in all likelihood, you would see the old woman. Yeah, well, there's the old woman, a little slightly changed there, but not too much. There she is. Okay. But if you go back here, if I had you to concentrate on this picture, okay, which is basically a young woman looking backward, right? There's the tip of her nose and so on. If you concentrated on that, and now we put this up, you would spontaneously see the young woman, okay? So we've primed you, depending on what I had you looking at for a number of seconds, to see the stimulus in the way that you were primed to see it, by focusing on the old woman or focusing on the young woman. This is an example of an ambiguous figure, okay, which can be seen in more than one way, okay, depending on how you interpret it, and that in turn would be affected by your expectations or your very previous experiences, okay, your most previous recent experience. When we talk about priming, that's a term that refers to, and we'll see more about priming, particularly when we talk about consciousness. Priming is basically making an idea. Some stimulus makes an idea or an expectation or a thought or a concept very salient in your mind. Then subsequent stimuli are presented, and you tend to interpret what's been primed in terms of we tend to interpret that new stimulus in terms of what's been primed. Okay, we'll see some examples of that as we push forward in the class. Okay, so we can move to context. Okay, context effects. So in which picture, okay, does the center dot look larger? Okay, most of us will say, okay, that this center dot looks larger than this one. In reality, they're precisely the same size, but you can see that surrounded by big bold dots here, okay, that context, okay, creates this, and this one's surrounded by little dots. These two contexts create what is in effect an illusion of a size difference, okay, between this dot and this dot. They're exactly the same size, but most people report that this one, against the backdrop of small dots looks slightly larger than the one that's against the backdrop of big dots. Okay. So this is an illustration of something that can be demonstrated in serial presentations, and but here they've got it all on one slide. Okay, so how we see this middle character depends on whether we examine the rows or the columns. So if you've been exposed to a series of numbers, okay, and asked to basically say them out loud or whatever, okay, when you get to this stimulus, okay, you're going to spontaneously say, because you see 13, okay. But if you've been exposed to a series of letters like this, when you get to this stimulus, you're going to see a B, okay, and you'll spontaneously see it. You won't see it. You won't see the 13 in the absence of having any numbers around, if it's mainly been letters that you've been exposed to. So it's a powerful context effect right there. So here's one of my favorite examples of context effects, which affects our perception of color. Okay, nearby colors, okay, influence how we perceive, how we interpret the color stimuli that are being presented to our senses. Okay, so in reality, okay, well, psychologically, perceptually, I think most people would agree, okay, that these pink, the little pink squares, okay, are a different shade than the pink squares going on the left, the bottom left, upper right diagonal, okay. That these going from the upper left to lower right, they look a bit of a brighter shade of pink than these do, okay. The ones that are surrounded by green context, okay. Well, in fact, those pink dots in both diagonals are exactly the same hue, okay, and saturation. They're exactly the same color, okay. But yet these ones look darker than these because of what's behind them, the context in which they're presented, okay. And note down here that if you ever looked at some of the op art from the 70s, you get a lot of cool perceptual illusions in that art because it capitalized on context effects in particular. All right. So it's not only expectations, okay? It's the emotion, physical state, and motivation, okay, all affect perception, or how we're interpreting the sensations that have been processed through the sensory system, but not yet through the brain, the perceptual system. So experiments show that, if you study people who are tired versus people who are very well rested, and you can, manipulate that. You can have people like, in one condition, exercising vigorously on a treadmill or in some other way, or doing something that's very strenuous, it tires them out. And then the control condition is doing something more sedentary and not something that would tire them out. And then you present them with a bunch of stimuli, ask them to make judgments. And for example, you might present people with a scene like this, okay, and ask people to estimate, okay, the distance from the beginning of the scene down to the end here at the rocky horizon. Okay, how long is this road? How far does it go? Okay, people who are tired, who have been put through the tiring task, okay, will report a greater distance, okay, on average, than people who are not. Okay, so our physical state can affect how we see things. A target looks farther when you are doing an archery task and your crossbow is heavier. Okay, that's been manipulated in research. Okay, so you're carrying, so something is heavy. The target that it's aiming at looks further away when you're lugging and aiming a heavy crossbow than with a lighter one. A hill looks steeper with a heavy backpack or after sad music or when walking alone. Okay, so all of these variables that affect our mood, affect our sense of being kind of fatigued, carrying a weight, all can affect this, what you would think would be a relatively objective, not so much affected kind of judgment of how steep a hill is. Okay, so those are some examples, nice examples of how emotion, physical state, and motivation will affect perception. Very important when we think of, different people, depending on their state, may have the same sensory surroundings, okay, but experience that world differently, perceive different things in exactly the same world that's out there. Something you desire looks closer, okay? Another effect of a need and motivation on perception. There you go. Okay, so here's more examples to ponder, okay, as I approach the end of this section. So perceptual scent. So we're continuing with the theme that attention is selective, okay? And a couple of examples that I really like, and the second one is actually an empirical example, but let's start with the first one. The botanist in the garden example. So if you imagine that you're walking through a botanical garden, beautiful, expansive, all these cool flowers and plants and shrubs and so on. It's a botanical garden, okay? So you're walking through it with a botanist, okay? Now, ponder the extent to which what comparison of what you're going to see and what she would see, okay? They would be very different. The botanist is trained, has a whole lot of knowledge about these things, is going to perceptually tune into aspects of what you're walking through, this garden, that you might not even notice. Okay, so experience and knowledge, okay, will very clearly affect what you versus the botanist, who has much more experience with this, literally see. Even though it's all there available, you don't notice these subtle things that the botanist will notice. So therefore, you don't perceive them. She does. Um, and hence we get this difference in perception. There are a couple of classic psychological experiments that illustrate the influence of perception or attitude. There's a number of studies that show this, but a couple of my favorite, one of which was done way back in the 1950s, and another one more recently. Well, that was done in the United States, and one was done um, in Great Britain. But let's talk about. So basically, these studies show that the number of infractions and fouls seen by fans watching the very same in the football or soccer game depends on who you're rooting for. Okay, you tend to see the other team, the one you're rooting against, as committing more fouls. Okay, so this was empirically demonstrated many years ago um, in a famous psychological study, which was published in an article. Um, they had the title "They Saw a Game?" question mark. Okay, because everybody was exposed to exactly the same game, okay, football game, clips from it, um, but came away with different conclusions. So this was a study that was done at Princeton and Columbia, okay, and so at the time there was this huge football rivalry between the two colleges. Okay, the Princeton team and the college team. They battled it out for many years. It was a huge rivalry, and there was a particular game in the sometime in the 50s that I don't even remember who won. I mean I wasn't there, but I read the article. But anyways, um, so Princeton students and Columbia students, okay, were asked to watch clips from the game. Okay, it was a nasty affair. Okay, lots of infractions, lots of penalties, called and not called, lots of dirty play, lots of rough football. Okay, and so what students at the two colleges were asked to do was to basically and try to be as objective as you can. We're seeing how good you guys are at detecting these things. Okay. Um, we want you to watch these large clips, film clips from the game, okay, plays and so on. And every time you see an infraction, okay, some sort of penalty, some sort of either called or not called infraction, okay, we want you to, mark it down, keep a count, okay, for either team. So after both groups of students did that, the researchers looked at the results, okay, and what they found was very interesting, okay. The Columbia students perceived that the Princeton students had committed um, more fouls, okay, than did the Columbia students, okay, the Columbia players, okay, whereas well, let's get this, let me straighten this out, say it more clearly. So if you're a Princeton student, okay, watching this, you see Columbia football players having committed more fouls, okay, and Princeton students or players committing fewer fouls. And if you were a Princeton student, it was just the reverse. Okay, so if you're a Columbia student, you're seeing um, you're seeing more fouls committed by the other team than your team. Okay, so for example, you might have, the typical Columbia student might have seen the Princeton committed like 5 infractions, okay, throughout the course of what they were watching. Whereas the same thing was watched by the Princeton student, they see the Princeton students, players committing maybe like 1 infraction, okay. So did they see the same game? Well, they were fans of one team or the other, and being a fan affected what they perceived, okay, in terms of how dirty the players were playing and how many penalties were committed by the two teams. Okay, so that was replicated a number of years later in a big study that was done in Great Britain, in which you had Scottish fans, football, soccer fans, and fans of the English soccer national team. Watching a game between, this is a huge rivalry between the Scottish national team and the English national team, and you got the same kind of effect. So that's a good example of how preferences, okay, in this case, the team you're rooting for, that you like, etc., versus don't like so much, affects how you perceive the game you're watching. Okay? And I'm sure all of you, you know, I'll close with, you know, my wife and I are always watching Knick games, and you know, I swear I'm the same way, but I'll pin it on her. I tell you, she sees the other team as committing so many more fouls, and the referees, you know, screwing the Knicks a lot more than she sees them um, um, doing the same to the other team. Okay, sees a lot of bias in the refereeing and in the play and so on. I do too. Okay, and maybe there is, you know, all of our, you know, but I don't think as much as we see. Okay, in fact, we talk about this, and I say, hey, don't remember the Princeton Columbia study, you know, and in any case, I think that is it for now. Okay, um, on perceptual set and with this narration. See you later.